Hello, 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 hello. Guys, good morning. I hope that audio and all that stuff is nice and cool. So yeah, before further ado, like first of all, how many questions you solved? And when I say how many, please write okay. Four, like when you say oh, like not four. If you say like three, then 1, 3, 4, or 1, 2, 3, like by the number of like what question you solved. I'll just quickly do a check of mic, and Rishi is here. Hi Rishi, hi, and hello, and who all folks are here, just quickly write down. Yeah, I'm back. So basically I just had to put a mic, I had to put it inside, so yeah, that's the reason we are here. Cool. Quickly, hi Rishi 3, Shubham, Aryan 4. Great Shubham, and others. NKVS 2 ने मार डाला, correct. Actually like 2 was so it's a bit tricky. Manmohan 3, great. When you say 3, can you just write down the number of questions you wrote, like the number of questions you did, all that stuff? That would be great. Cool. Anyone else? Oh, I forgot to actually open this stuff. Cool, so that I can just see the chat here. Right. And like so. Third was nice. Yeah. 2 ne mara. That was actually yeah. Fourth one was like we can actually complete this one very early because the questions were easy. Not that hard. To be frank, Akash Sardar. Okay, 3. शुभ 2, 3 में लॉजिक समझ आया बट कोड नहीं हो पाया. 2, 3. 3 was actually like just implementation and stuff. So yeah, but if you get the logic, then fourth question solve नहीं हो पाया. No worries, Manmohan. No worries. That was actually like normal. Oh yeah, before further ado, if the folks are watching, I forgot to tell. The folks are watching, can we have at least the likes of number of folks who have joined? For sure, the folks who have joined are the regular ones. So if you are the regular ones, then please, एक like तो बनता है ना. Cool. Akash, no worries, Akash. No worries. We will see every question, second, third, fourth, everyone. Like we will see every first even. Like we will see even first question. But yeah, Shubham Aryan second and fourth was interest in. Nice. Yeah. Second and fourth was actually interesting because that was right. But yeah, before further ado, can we have likes at least 10 so that we can actually start off? We'll start off very soon. That was great. Cool. We'll start off very soon. Just a quick seeing that, okay, what you guys did. Lokesh Khandilwal, roadmap for Faang for tier 3 college, 6 SEM CSE student. Roadmap is coming super soon. For sure. Shashit Pandey, भाई 2, 3, 4 ने हिला दिया implementation में. Correct. I should say correct that I was actually, because see, 2, 3, 4 was actually nice. So especially 2, I see. If I had to rank the problems, I will rank the problems as 1 very easy, 2 medium problem, especially like not to think. Okay, to actually think, it's a simple recursion with DB, but then it was a bit confusing that you placed this problem at number 2. I should have placed this problem at number 3. That's the reason. Cool, no worries. Number 3 problem was medium to easy-ish because it was actually a very common problem. Fourth was also a very common problem. So yeah, it was so easy kind of. Yeah. Vamsi, hi bro, I have finished my masters. I am aiming for Faang but couldn't solve second one. No worries at all. No worries. See, there are a few times that even if we know DP very well, even if you know like recursion very well, still the things could not strike because of some movement issue, some other thing going on our mind. Maybe we are thinking of it as very easy thing and we are thinking, okay, maybe it can't be implemented and stuff, but still, it is not that okay, we can't do it. But if we can, if you did second question, or if you cannot do second question, but if you did third and if you even tried fourth, that is actually great. Akash, first, third, second, fourth. I'll rank kind of first, third, fourth, second. I don't know why. Like kind of you can rank fourth also because fourth is just a mixture of multiple things. As in the last video of our like which we had, okay, the OA video, if you have watched, I just actually specifically showed that, okay, the combination of problem make the problem hard. It's actually easy. Just the combination make them hard. And we have to just individually learn the combination and to actually see, okay, how, because see, the fourth question was the implementation of graph and like number theory. So it's just a combination of graph and number theory. And the roadmap and the sheet which is coming up, that will actually show you these combinations itself, so that you like, it will be very easy for you to actually solve these questions. But yeah, before further ado, we have 22 viewers. Can we have 20 likes? I'm just seeing right now it is fluctuating 50, 60, 50, 60, 50, 60, like a person is playing with the play button, like like button. I don't know why, but yeah, cool. Shubh, DSA में topic wise concept वाली question कब दोगे? See, that questions are ready. It's just that the all editors just नहीं हुआ, अभी नहीं हुआ, ये वो. Probably by Wednesday the video should come for sure. Lokesh Khandeva, appreciate it. Thank you, bro. Shashwat Pandey, could you tell us 2, 3, 4 crisp problems say if they are not new? See, like when I say not new, it means that they are very standard concepts, right? Question number 3 was actually a simple concept of products, which means whenever the products can be high or positive. So there's a standard problem. Okay, whenever the product can be positive, we just have to get that positive, and that is itself. I'll just find out if I can find the problem, but yeah, it's actually very standard stuff. And the question 4 is just actually if you just go on the logic a bit, then you can easily see whenever the questions like this come, like okay, prime factor, all that stuff. So we actually see, okay, it's still 5 minutes, but yeah, we'll actually start very soon. So like whenever these question comes, okay, actually the problem itself, I will show that how to think of that stuff. But whenever the problem comes, like okay, they have some factors, the GCD and stuff, so we try to bring out the factors, and from that we start thinking stuff. And whenever we bring on these factors, and then we can easily, okay, it has a factor, it is being connected, okay, it's a graph. So as we just draw a line, that line draw shows, okay, it's a graph. But as we bring in the factors, we show, okay, it's a number theory problem. So it is just that small things we just go on, and by that we build the answer. How to dive deep into DSA? It's nothing but, see, the more problems you solve, see, DSA is never a fixed, it's just a C, right? The more you go into it, the more newer problems you will find, the more complex combinations you will find. It's just that, just get mastered into small concepts, and then you would be very good to go. So it's not a deep dive itself. Just grab the basics, surface level, and just like have the problem solved. That would be good. 4 with no WAs, 4 with no wrong answers. That was nice. It's entirely on how and what sieve you choose. There are 2 sieves, like the normal one and the bit longer one. So if you have used like normal one, which is I into I is less than max, which means it just goes up to square root of n, then it would have passed. But if you have used a bigger one, so basically a sieve has n log of n log n, log of log n, like complexity. But yeah, there are many ways in that. With 4th question, I was able to get the intuition of prime factors and union find, but unable to solve it. That happens. Maybe the practice of writing stuff is not that much fast, but yeah, it's just out of, we try to solve that stuff. We just get familiar with it much more, and then we will just easily be able to find that stuff. But yeah, before further ado, we have many folks join. We will start very soon. Just that, can we reach 25 likes? That would be great. Cool. Himanshi, can second question be done without DP? I guess no, because greedy won't work. Recursion won't work. Because see, why greedy won't work, I'll show. But recursion also, you for sure know that, okay, because it has a repeating sub problem, and if we don't repeat, and like if we not memorize that part, then it will just go exponential, and that won't work in a complexity. So what I think, maybe in the best case possible, there may be a solution, but at the top of my mind, I cannot think that it can work without DP. But yeah, we can actually for sure try your ideas and all that stuff. If you have any, then I would be great to consider them. Elastic. Bro, I'm doing DSA and CP from last 6 months. बीच में अब गैप हो गया पेपर पे के कारण, कुछ याद नहीं है, डिमोटिवेट हो गया हूं. That is exactly my condition. I started CP 2 years. After 2 years, can you just imagine मेरी क्या हालत हुई होगी? It just takes a month to actually brush up, because see, as you just get to know things, it just becomes much easier. See, it's just initially that when you are learning, it takes time. Even if you had a long break, it is just 6 months. Even if you have a long, let's say 1 year and a half year, let's say 5-year break, still to get back on stuff, it's much easier. So it will just take a month. Just give contest, make stuff, solve problems, and you would be good to go. We have many folks joined. Can we actually reach the likes to 30? And that would be great. And for sure, we are starting in a minute. We will start exactly at 11. Just a quick thing, but yeah, we're starting at 11. But yeah, meanwhile, can we 30 likes? That would be great. Last दिव्यांश 3 solve हो गया था, पर एक edge case नहीं हो रहा था. There are few edge case in 3 questions, so we'll consider all of them for sure. Gautam, why can't you start a training program in DSA? Because explanation skills is next level. It needs time, and I don't have that. So for sure, until and unless I can properly commit on something, I will not start that. Which means, firstly, I will finish the bar graph series. Only then I will start any other thing for sure. So firstly, I had to make sure that I finish one thing which I started. Which means if I commit something, I will finish that, and then only I will just start with another thing. That's the reason I have not considered these kind of stuff. And also, like, we have the VP program, I still, like, as soon as it, like, the video itself, it passed 1 day, I closed all the registration, because I did not want it to spend much time in that, because for sure, if I cannot give time, then all your promises will go vain. That's the reason I just had to fix on the limit. Okay, how many people or how much time I should give them. Cool. We have 11 now. We will start with the problems itself. Let me quickly share my screen, and we'll go on to the comments later on. But yeah, meanwhile, if you're just liking it, if you like it, because for sure we will just quickly wrap up the easy problems, then we will go on to the hard ones, which is second, third, and fourth. Cool. That is very easy. Okay, it's a 4th problem. We will go in the last. But yeah, meanwhile, starting off with the first one, buy 2 chocolates, for sure. Buy 1 for me also. Basically, we are given an integer called as prices, representing the prices of various chocolates in a store. Cool. You are also given a single integer array called as money. You have an array called as prices. You have an integer as money, and you must buy exactly 2 chocolates. Mark my words, exactly 2 chocolates in such a way that you still have some non-negative leftover money, which means money should be equal to 0 or greater than 0, right? You would like to minimize the sum of the prices of 2 chocolates, which means I will take the sum of minimum 2 chocolate prices, right? Which means the prices of the 2 chocolates that are minimum, and return the amount of money you will have left over after buying the 2 chocolates. As simple as that. If there is no way, okay, cool, then return the money itself, which means if you cannot have the leftover as 0 or more than 0, you have to return the money itself. Look at the first example. We for sure know we have to buy exactly 2 chocolates. We will always try to take minimum price of these 2 chocolates, which means 1 and 2 we will take. Money we have 3, prices was 3. 3 minus 3 is actually 0. Thus, I can return a 0. Here, I will just try to take the minimum 2 chocolates prices, which is 2 and 3. Sum is 5. Money I have is 3. So 3 minus 5 is minus 2. But I was saying that I want the leftover as non-negative, which means positive or 0. So I cannot take this negative, so I can return the money itself, and that is the answer. Simply, I can just simply grab 2 variables, or I can simply sort this particular, because the constraints are pretty low, I can do anything I want, but best, whatever you want, grab 2 minimum as you want, no matter how, just grab it. And also, other ways, just sort it down, grab the first 2 prices and have its sum. Let's say the sum is sum, and then you have the money, you have the sum. Just see if the difference of money minus sum, if it is more than equal to 0, then return that money minus sum. If it is less than equal to 0, then return our money. It is as simple as that. Let me quickly switch to the code. It's pretty easy. I'll quickly show that. But yeah, meanwhile, if any of the folks have doubts, just comment down below. We'll quickly jump on to the comments, and then we will actually start with the next question. Cool. So as you will simply see that you have this sum. I'll just quickly zoom it up. You have this sum, which is, firstly I simply do a sort of this my prices array, and then I have this sum. Then if I just check, okay, if the sum is more than or equal to 0, then return the money minus sum, else return the money itself. And that is all in the first question itself. Now let's quickly jump to the next question, which is the question number 2. That is actually a nice question. I swear, for question 2 with 4 score, this is the nicest question I have seen lately. But yeah, I'm not saying it is very unique or something like that, but yeah, it is actually a nice question. If you have not solved it, no worries at all. It was actually, I think it is harder than the third question. So for sure, it's actually great. But meanwhile, if the folks are liking it, joining us, then please, can these are 40 likes? Just 3 more, just 3 more. Smash it, spank it, all your angriness, just like have it on your like button. No worries at all. Cool. And problem name is extra characters in a string. Just a quick fact, you know, like all my neighbors are disturbed of me. Like legit, all my neighbors are disturbed. I just saw a message on WhatsApp that like a person is teaching in the night. Please, he should lower his volume and all that stuff. But still, we will not. Yeah, that is for sure. Extra characters in a string. Let's have it. You have a zero index string S. And a dictionary of words called as dictionary. Cool. I have a string S. No worries. Zero index as usual, as for sure. And a dictionary of words called as dictionary. Cool. You have to break S. Mark words. Break S into one or more non-overlapping substrings, such that each substring is present in the dictionary. Cool. Is present in dictionary. Now, there may be extra characters in S which are not present in the substring, which means I had the string, I broke it down into multiple substrings which are present in my dictionary, but there can be a chance that a few characters were left in between. Those were not inside that substrings. So I have to tell, okay, what is the minimum number of extra characters left over if I break S optimally? Okay. If I just break S optimally, which means if I have this string as Leetcode, then what I can simply do is I can just break that to Leet, which is Leet here, code, which is code here because it is in the dictionary, and Leetcode is not exactly here. So I have this one character left, which is S. So I'll just simply return, okay, minimum character which actually can remain extra left over is actually a 1. Right? Let's look at the next example. I don't have S, A or Y. No worries at all. Like nothing like that in the dictionary. Cool. I have hello. Okay, I will just grab this hello. I will have a word. I will just grab this word. Then I can simply have a 3 letters remaining. That's the reason answer is 3. It's a minimum number of letters. We see the constraints. It's pretty low, but for sure. One thing I have to break S into one or more non-overlapping substrings, which means I have to indirectly match this particular string with kind of every starting letter as such, right? Now, I'll just quickly ask you guys what you did and what are, see, yeah, Abhi, no worries. I just quickly ask you what you guys did, and for sure, you guys wanna talk about greedy approach or something like that. I'll quickly go over to the greedy approach, but quickly, what you guys thought of it? What was the issue in this problem? Just let me know down below so that I can actually know how to actually modify your thinking, that next time you will think of something like this. But quickly, meanwhile, while you guys write, yeah, it can be written by try also, because for sure, try is nothing but, let's say if I have a hello, I have this main string, so I can just match the letters and then implement by try. But implementing a try at this point of time, which is because see, you have very less time, right? If you are good with try, good. If you are not, we are very much familiar with DP and recursion stuff rather than the try stuff. Try is actually can implement this problem, but I'll not recommend that way for this problem at this stage, provided you don't have much familiarity with try. If you are good with it, you can implement it fast, very good. think of it. But standard stuff which comes in your mind by seeing the constraints itself, okay, it's very low. The constraints would have been high, try would have been good. But yeah, it's low. We can actually think of recursion at the first stage itself, and then we can just initially start off with, okay, what can happen and what cannot. Greedy, okay, I use substring, that is correct. Okay, yes, greedy, okay, cool, we will go with the greedy one firstly. But yeah, that is not sure, that is not correct. But it is giving more values than expected. I thought it was a greedy but couldn't figure out how. No, it was not a greedy. Firstly, extract the intervals and did DP on those intervals, correct. Can you do it with memoization? Yeah, I did it with memoization only. I tried it using hash maps. We can use anything, hash map, unordered set or anything. I tried using backtracking. Even WA backtracking as such is not required for this, but yeah, it's simple recursion. Cool. Was to delete every occurrence of dictionary item from the given string and just count remaining characters. Was it correct? You're making it hard. Like, you can actually implement it, but still have to figure out some edge cases and stuff. Let's go look at, okay, what actually, firstly, if I have, let's say, something like this, right? Now, one thing which comes to my mind is I will just grab this hello and I will just try to map in my string, because I will just grab the first letter of my dictionary. I will just go back in my string and I will try to find that particular occurrence. Okay, I found it. Very good. I will just know, okay, this occurrence I have found. Right. Next occurrence, I will just go and try to remove that occurrence. Right. Then ultimately, when everything I have tried to remove, then I will just say, okay, the last thing which is remaining is this say, which is 3. It is the one of the greedy approaches. But how it will fail is, what if I have something like as hello, but then I had no word. Let's say I had a LLOWORLD, right? Then what you could have done is, if you would have done, okay, hello is gone, then I will just try to find for something remaining part, but I could not because it is LLO world. And then you will try to put it here, but it will not put, and for sure it is already gone. So you will try to put it here, but it is not here. So you might return, okay, SAY and world, which means 3 plus 5, which is 8, but it's not the correct answer, right? The correct would have been if this LLO world would have been there and then you return a 5. But Aryan was said, okay, maybe I will just try for every word, which means, okay, I will just try for this word itself and not this word, hello. But then I will just say, what if something is again repeats, which means what if another overlapping stuff, which means with this LLO word, another stuff which is overlapping, it repeats, and multiple overlappings are repeating. Then how would you say what will come? You cannot, because for sure one thing will come in your mind is, okay, shall I take this part or this part? Because see, when I say overlapping, I mean, okay, this is a dictionary and this is my string. Now what can happen is my overlapping part, okay, one is overlapping like this, one is like this, and one is, let's say, like this. Okay, it's very big, let's say it is like this. Another is overlapping like this, one is overlapping like this, let's say, and then one is like this. So it is very confusing. Okay, what all to choose? Shall I choose this one or this one or this one? Like which one? Because if I take this, then I have to take this and this, but maybe it is acting as this here. It's a string of dictionaries, which is these strings. So ultimately it will just create confusion in such a way that you won't be able to figure out, okay, what is the minimum I can actually grab in. Thus, the best is to go via all the ways, which means I will just try to find and map every part, which means I have this string. Let's say this string is S. Let's grab this string only. Let's say the string name was leet S code, right? Leet S code. Now, one thing I for sure know, if I am starting at this character, right, what can happen? What all thing can happen? Fun thing can happen is, maybe L is here, maybe L in my dictionary is there, maybe LE is there, maybe LE is there, maybe LET is there, maybe LLTES is there, maybe this is there, maybe this is there, maybe this is there, or maybe this is there. It can be there. For starting at looking at my string, I can just imagine, okay, maybe L is there, maybe LE is there, maybe LE is there. When I say LE is there, here as in the dictionary itself. Now, what if L is skipped? Which means, as in the case of this first thing, the S was skipped. But here my LET was there. But yeah, S was skipped, right? So for sure, one option other can be L is skipped. So basically, I have firstly these options for this particular index. For this index I have option to include L or LE or LEE provided it is present in my dictionary. So I'll just have, okay, in my dictionary, I have to find, hey, is L is present? Let's say he will say no. Cool, I will say no worries. You can just go and have and look at the next one. We will see what is the next one, but then he will just go and check, okay, is LE present? He will say no. He will ask, is LEE present? He will say no. Is LET present? Yeah, there is present. So basically I know I am trying for this index, I am trying for every substring, and also I will try for one case when I did not even consider this particular index, which means I did not consider, I skipped that. I will just directly move on to next one. Again, I will do the repeat. I will repeat the same stuff. Okay, E, EE, EET, EES, EEC. Again, same stuff. And when I'm saying I'm skipping it, remember, I am skipping it. I am skipping it, which means I am increasing the count of which I am leaving. Count of characters which I am leaving. For sure. If the folks are liking, then can you please smash that like button? Can we reach to 55 likes? That would be great. Cool. Meanwhile, what happens is here I will just again go and check. Okay, is EE, EET, EETS, and again so on and so forth. And also one case will be when I skip this particular thing. But whenever I'm skipping, I have to add a +1. But whenever I'm taking, okay, let's say LETS is found. Very good. I will just directly go to the next S, which means in our case, what happened was LETS CODE, right? When I was here, I was trying for everything, this, but no one I could found. But as soon as I found a this, I will just quickly jump my index to this and I will start checking from here. Then again, I will just repeat the same process. This, all the stuff. But then ultimately no string of SC, SCO, SCOD, SCODE, nothing was found. No worries at all. Ultimately, it just went on to skipping this. It's a one option of skipping, right? Then it went on to this C. It tried for C, CO, COD, CODE, and ultimately it can just go and see, okay, COD is present. Now you saw, okay, I'm trying for every possible way. Now, recursion looks fine. Recursion is actually, we can see it's a recursion because for sure I'm trying. If I was here, I tried every way. Basically grabbing this, which means let's say if the length is n, then I tried for all the n ways of this particular index I, and then also one way of leaving that index at entirely. But then Aryan, if it's recursion, which means for every character you have two options to take it or to not take it. But then, can you think of how you thought of it as DP? Like for sure, if every character has an option to take it or to not take it. When I take it, I take entire stuff, which means I take it with this, and one option was to not even take it, which means leave it. For sure, it's kind of a knapsack kind of thing. But how to know that, okay, it has a repeating sub problem? As simple as that. If we just make this string down, right, then for sure it can happen at one point of time. This part is in my dictionary, and then let's say I skip this part. Now I have to try from here, right? Let's say I am here. Now other option it can be, it is in my dictionary. It is like this. Now maybe it is in my dictionary. It is in my dictionary. Now I have to again start from here. You saw what happened? You are starting from here and you are starting from here also. This whole part was done. Okay, here I will just say 1 is the count of extra characters which was there. Here the count is 0 because I found everything. But still, to find the answer for the rest of the part, it's a repeating sub problem. That is the reason whenever I was applying a recursion, because it's a simple index, I just find, okay, from this index up till end, what is the minimum number of characters I need to remove? And that is a kind of a repeating sub problem because it is same for both of them. That is the reason I can simply do a memoization with a DP. As simple as that. A simple recursion. And as I showed you, how a simple recursion, going on to each index and just check for all the substrings starting from that index, which is n substrings, and then one option is to leave that index entirely, which means okay, skip that index, because we can also skip that. But whenever we skip, we know we have left one character. So for sure, please add a 1 and then return that 1 ultimately. But ultimately, I just did this recursion, and ultimately I know, okay, I have a repeating subproblem because I could visualize that, okay, maybe it can happen like this. At this point, the index can reach, and the part which is before, it can be different. With the later part, it can be same, which means it can have a repeating subproblem. That's the reason I can know, okay, I have to do a simple memoization in my recursion and I would be good to go. That is how we can actually solve this problem. Let's quickly see the code. It's very, 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 very easy. Simple, like very simple. Firstly, we just had our DP initialized. Let's forget for now our DP is initialized. Let's have a simple recursion. Simple recursion function. Firstly, at a point of time, I said one thing. If you just remember one thing in the code, I said that at a point of time, you have to figure out that, okay, this LE is in the dictionary, this LEE is in the dictionary, this LEET is in the dictionary. So basically you have to find, okay, if that particular substring, because you are at index ID, no worries at all, but then you take a substring of some specific length, but then you have to find, okay, is this substring inside my dictionary or not? If it is, I can just simply move on to the next. But if it is not, I can't take it. So to find if it is in my dictionary or not, I can simply use this dictionary, because it's a simple vector, right? It's a simple vector. I can transform this vector either to a hash set, either to an unordered set or an unordered map, right? So to actually find an O of 1, then okay, is that string actually in my dictionary or not? Because either one option is to iterate on the entire vector and find, okay, if it is in my dictionary or not, but it is useless, right? You can simply convert this dictionary into a convert this dictionary into a unordered set or an unordered map, simply by just to know if that string which I am considering, which is that substring I'm considering right now, if that substring is in my hash set or is in my map or set or not. That is how you can simply find that if it is there or not. So simply I just use a set, unordered set. You can use unordered map also, exactly same, no worries at all, same complexity, everything same. Then I have this recursive function which grabs in my string. For sure I have to operate on strings, so I need my string. First let's check, okay, yeah, and then I have start index as 0, because I know I have to start from index 0, because I have to go on every substring, right? Then I just have a base condition. For sure it occurs, okay, your ID, which is your index, if it reaches the end of the string, for sure you have to return a 0, because everything is done, right? Base case, if it is already computed, which means it is not -1, return simply a DP. Now comes the interesting part, that I want the minimum, you remembered, I want the minimum number of extra characters left. So I initialized my result as maximum, which is int max. Now I went on to every substring possible starting from this index ID. Now to grab the substring in your C++, you take the length. So that's the reason I take this length as I. Now I'm trying to grab every substring, considering, okay, starting from I, because it is the ID, starting from this ID, if I just have this length I, then it should be under my length limit. Now for sure it will go and try for every length possible starting with this ID, which means starting with this ID, it will try to have every substring. I will just grab that substring, let's say name it as T. I will just check, okay, if that substring is in my dictionary, because my dictionary, I transform that into my unordered set. I will check in my unordered set if that substring is present or not, and the substring is T. If that is present, great. But if that is no, so if that is present, great. I just simply go and check, okay, what is the result? And then I'll simply go and say, no worries, you have just grabbed this substring of length I. You can just go and start with the next character at index ID plus this length, which is I. So I'll just go and start with the next character, which is ID plus I. Now, what if you tried for every length, but you could not find, or maybe if you find, still, even if you find, or even if you could not find, still you have to try and skip the first character itself, which means you will skip the first character and see, okay, one character is skipped, so one I have given, one I have left, so one is added, and then I skipped and just went on to ID plus 1. That is how you tried for every substring, starting with this index ID and then skipping that. And I'm saying, no matter if you grabbed a substring starting with the ID or not, no matter what, you have to try and skip that also. Aryan, why skip that? Because see, it can happen in such a way that, okay, you had, let's say, LE in the dictionary and you also had EETSCODE. If you had only grabbed this LE and then moved on to this E, then it would try and check this EETSCOD, but it is not in my dictionary. But if it would have skipped and then would have gone on to next E, then it would have gone and saw this EETSCODE and it would have said, okay, the answer is 1. That is the reason it's important. Even if you find in your dictionary, it's important to figure out, to actually try on every way. When I say every way, I mean to actually skip that also. And that is how you will simply get the result and ultimately return that result in your DP, because ultimately you are memoizing this part. So for simple memoization, we just added a DP statement here, added a DP return statement here, and a simple initialization of DP. And that is how we converted our recursion. And simply, and a very simple recursion. Try for every possible substring and then check if that substring is in my dictionary or not. If it is, simply go on to the next part of that, because you have just grabbed that substring. So you will just go at the end and just try for that new part of the string. Even if you find or not find, so still try to skip that particular character and then go on to ID plus 1. This is the two options, which means skip that character or take that character. When I say take, I try for every possible substring starting with that character. That is how you will solve this problem. And that is how this is done. Cool. I hope that this was understood. I'll quickly jump onto comments. But yeah, before that, if we can actually reach to 50 likes, that would be great. If we can, that would be great. Let's quickly jump onto comments. But yeah, just 2 more likes. Just two more. Cool. Hash map or try. We can for sure extract the intervals and did DP on those intervals. I thought I've read these. Could not implement. Yeah, sometimes for recursion we can think of stuff, but we cannot implement. So it happens a few times, but we will just try and have that stuff going on. So we can just do it later on. No worries. My logic of second was to delete every occurrence of dictionary item from the given string. No, that won't work. And just count remaining characters. Was it correct? Nope. Occurrence of string you cannot delete, because what order you will decide to have that occurrence deleted. So that won't work. A8 high. Maybe it is abhi. If we delete the occurrence, then new substring gets formed. And here comes an issue. Correct. That is correct. Infinity Gaming. Yes, same approach. Monday, I also tried with visited approach. That is also incorrect. I showed you why. Because you can have an overlapping part, which means you will say LE can be deleted and EETSCOD can be deleted. So by your visited kind of thing, it will say the entire the entire leads code will be deleted, but it is not the case. So yeah, that is also not gonna work. That visited part. For sure. Abhi, did it work? Shashwat Pandey, no, that is not gonna work, but still. Bhaiya, DP मजबूत कैसे करूं? Practice करके भाई. Shashwat Pandey, no, that is correct. Abhijit Roy, does S.find work? S dot find. S is, you mean the string or the set? If it is set, yeah, it works. String, you have to check. I guess not. Harsh Sharma, save to watch later. Kal dekhunga subha. Thank you, brother. Subha contest hai, so don't know when you will watch that, but still, no worries, Harsh. Infinity Gaming, भैया मैं आपके लेवल की कब बनूंगा भाई? See, it's not a level, it's just that a few times it's good, a few times it's not. No worries at all. We are just learning together, grabbing together, reaching together, so no worries at all. We are actually growing together for sure. Infinity Gaming, Ajit Shiva, clean code, -2 Messi. See, in contest, you have to write the code. No worries if it's a messy or a clean. My question third code is super messy, but still, I'll try and show you the clean one if there is on the in the discuss page. But yeah, mine is super, but the concept is easy. I show the concept. Implementing that part is up to you. Cool, cool, cool. We have the folks joining in. Can we reach 6 likes? We have reached. Thank you. Cool. -2 Messi. My clean code. No worries. Never seen second question in LC contest uses DP. That is correct. That is a confusion of mine too, Pranay. Empire Gaming. Waiting for the last question. For sure, we are coming in very soon. Abhishek, for dictionary QN question, you thought of one-to-one mapping of substrings with dictionary words during contest. Yep. So basically I thought, okay, maybe I can just replace that part of in my string itself and maybe it can work, but then I figured out that it will not by showing the example which I showed you right now. Maybe it can overlap, and then by overlapping I won't be able to figure out which substring I should take, this or this. That's the reason it won't work. But yeah, I thought of that part also. Would you stream the contest solution after tomorrow's contest? Yeah. If yes, what time? 11 a.m. 11 a.m. for the Sunday's weekly contest and 11 p.m. for the Saturday's bi-weekly contest. But yeah, questions are done. I hope that is done. Let's quickly jump on to the third question. It's actually easy. What I thought was, but yeah, cool. Third question, but yeah, before that, can we show 65 like that? Would be great. 65, just 4 more. Cool. I don't know why, but yeah, that looks great. Cool. We have folks, we have the enthusiasm, we have the graph going up, but yeah, cool. Let's quickly jump on to the third question. For sure, what I thought was it was a bit standard. When I say standard, it is a very standard question of finding the products as maximum. I'll show also that the next time, if you have not done this question, for sure the next time you will be able to do it very easily. Going on to the question itself, maximum strength. But yeah, meanwhile, can we just 65 likes? 65. Bas. Cool. Maximum strength of a group. You are given a zero index integer array called as nums, representing the score of students in an exam. Cool. The teacher would like to form one non-empty group of students. Mark words. Non-empty group of students with the maximum strength. And how is the strength defined? Strength is defined of a group as the specific indices and just grabbing their multiplication. Basically, indirectly it is saying return me the maximum multiplication, which means I choose a subset from this particular group such that the product is maximum. As simple as that. When we say product, we say of numbers, right? Numbers, it can be either positive or negative or 0. As simple as that. And we know the numbers are gonna be producted, which means the number, we will have a simple product of them, all of the numbers. So if we are gonna have the product of all of the numbers, as simple as that, we will try simply. Okay, positive numbers, it will always increase my product. Cool. It will just increase my product. If there are positive numbers, I will just for sure try to grab all the positive products, right? Let's say if I have positive numbers as A, B, C, D, I will just have A into B into C into D, right? Negative numbers can help us increase our product only and only when we bring them in pairs. Why, Aryan? Because negative into negative is positive. So for sure, because see, ultimately my mind is working on, okay, I have this array, I have to make the product as maximum. Now product is of numbers. Number ka product is maximum only when we are just having numbers again and again and again. So just break it down to only positive numbers, only negative numbers, and only zero. Just break it down. Let's imagine I had only positive numbers, I had only negative numbers, I had only zeros. See, this kind of concept of breaking the numbers to either positive, negative, or zero, it works on if you have to find the products, if you have to find the sums also, it actually works on. So whenever you have to find, okay, find the maximum product, find the maximum sum, just try to break it down to numbers, what numbers you can have. By that numbers itself, it is a high chance you will be able to figure out a pattern. Okay, by adding the positive numbers, I will increase the product. By adding the negative numbers, I will increase the negative sum, like this kind of. Okay, cool. Let's come back to the product thing. If I had only negative numbers, then let's say it is -2, -3, -5, -1, -9. Then one thing for sure, I can also have a negative product, because I know one thing, negative into negative, it makes positive. So I will try to take two negative numbers and that will become a positive number. But, which means I will just grab these two numbers also. But Aryan, which two numbers to grab? Can we grab the consecutive numbers? I'll say maybe not. Why maybe? Because you will see, ultimately, if the number of negative numbers are odd, which means one number will just remain. One number will not be considered in our pair. One number will just remain. It can't come. So for sure, I know I have to leave one number. What number I should leave? Which has the minimum absolute value. Why? Because ultimately, if you would have left one, your product would have been 18 to 15. But if you have left, let's say 5, right, then your product would have been 18 into 3. You got right. You will just try to leave the number with the minimum absolute value, provided if the negative numbers are odd, right? Okay, cool. You got that? Okay, if the negative numbers are odd, I will try to take or leave one and take the rest, but rest all should have the absolute maximum values, which means I will just leave one number, because see, it can happen, okay, -1 is here, -5 is here, it can happen, right? Then simply I will just try to leave this number which is having absolute minimum value in negative, and ultimately I just grab the rest of the numbers. Now Aryan, for sure, if the folks are watching and the folks are liking it, then can we please hit the like button? That would be great. Can we choose 65 likes? 65? Cool. Now the last option was to actually go and get the 0, but if I had the number positive, I am building the product. If I just multiply it by 0, then entire thing will go in vain. I have built such a positive product, but then as soon as any number multiplied by 0, it becomes a 0. So I will not choose a 0, provided I have something like my positive. I will never choose a 0, or even I have a negative number of numbers which is more than 2 or more than 2. I will never ever choose a 0, because ultimately if I have the numbers as negative which is more than 2, I can easily make some pairs out of it, and simply I can just get a positive product. So if anyhow I can get a positive product, which means if I have the positive numbers itself or the number of negative numbers which are more than 2 or more than 2, I will never ever touch 0. But what if I had a one negative number, right, and also 1 0? Then what is better, a negative number or a 0? For sure, we want to maximize the product. So for sure, a 0 is better, provided I have one negative number, only and only one negative number. What if there is no number which is negative? Then okay, for sure, if the no number is negative, if the no number is positive, then for sure 0 is the answer itself, right? That is, we have to just bifurcate our problem into 3 steps. That okay? I will just firstly see, This problem, it can have many ways to solve. We just went on to the most basic, most greedy way possible. Just grab all the positive numbers. Simple. Because positive numbers for sure will increase the product. No worries, no thinking at all. Now, thinking of the negative numbers, I have to check, okay, if the numbers are odd or even, no worries. I will just try to take the even number of numbers, and if the numbers are odd, I will just remove the minimum absolute number. See, if I want to perform this, I can simply do a simple sorting, which means converting all these numbers to positive numbers. 1, 2, 3, 5, 9. Now simply sort it, which is 1, 2, 3, 5, 9, and remove this part, take only this part. Or you can do a vice versa also, which means sort in reverse order. You can do anything, just that remove the absolute minimum. When I say absolute, because the numbers are negative, so I'm saying absolute minimum. That's the reason. Just remove that and just take if the numbers are odd, because I want to make the pairs. So I want, okay, to grab the odd numbers, and thus ultimately just have remove that, just grab the product and simply add in the product. But what if you have no positive and the negative is also only, let's say you have no positive, you have only negative. Now if you have only negative, you will again check, okay, if it is odd, you will try to remove the minimum absolute, you will try to remove the number which have the minimum absolute value. If it is even, you will try to take all of them as usual. What if, Aryan, you have only one odd number? Then for sure I will just say, okay, if it is one odd number, do I have a 0 with me? If yes, then for sure I will never return a negative number, I will return a 0. But if I have no 0, because I know I have no positive, I have no 0 also, then for sure you have only one number which is negative, return that. Your luck is not working today. Cool. But let's say if I had a 0, I will return a 0 instead. And simply, last case was I have no negative at all, simply a 0, I will simply return a 0. Thus you saw that, okay, I bifurcated the problem. Positive, if positive, then okay, if negative, cool, if not positive, then okay, if negative, cool, if not negative also, then okay, if 0. It is just a 2 if else, okay, if else, and then from this else again if else, as simple as that. Or see, the code, the approach remains same, exact same. It is just that how you implement this condition of if else. You can make the code very short also, but in the contest I want to do it very quick, so I wrote the very big code, which means every part I just wrote down, whatsoever I'm thinking, whatsoever I'm saying, I just wrote it down. But meanwhile, can the folks reach the like count to 7 likes? That would be great. Great, cool. Let's quickly show you the code. It's actually very simple, just implementing these conditions of if else. So we initially started with answer. I'll go into the comments just after the code explanation, but yeah, you can just write the comments down. I'll just quickly go into them. So yeah, you can just, any questions, doubts, anything like that, you can just write that down. I just have the vector as positive, negative, and 0, because I told you I just bifurcated that into 3 sections: positive, negative, and 0. Then I just pushed in all the positive numbers in my pos, all the negative numbers in my neg, but considering the absolute value of those numbers, because the numbers are negative, so I just did a minus to bring them as positive numbers, because ultimately my product is always going to be positive. So I just thought of, okay, just transform all the numbers which are negative to actually a positive number. Then I pushed in my zeros, as simple as that. Then I know, okay, I have to grab if the numbers are negative and if the numbers are odd, I have to remove, or I have to not count the number which has the minimum absolute value. So I just sorted my negative number array in the reverse order. And when I say reverse, which means 9, 5, 2, because the numbers have been converted to the positive numbers by this minus sign. Cool. Now the same condition which I told you, firstly if condition, if I have a few positives, then I'll just simply go and find the product of all the positive numbers. But I'll just check again, if I have the negative numbers also, then simply go and grab the all even negative numbers. which is the from 0 to the size. If it is odd, I just reduce the size. As simple as that. Now, it is the condition, okay, if I have the positive numbers, what if I don't? If I don't have the positive numbers, then simply go and check, okay, if the numbers are negative, simply grabbing, okay, negative numbers, count. If it is odd, just leave the last one, which is, if it is odd, leave the last one. If it is even, then simply grab the pairs, as simple as that, which means just multiply all the numbers which are negative and you will get the answer. So it is that, okay, if I had some negative numbers, what if I don't have the negative numbers at all? No worries at all. I just said, okay, I have more than one negative numbers, which means I have at least 2, 3, 4. I have. But if I have, let's say, one negative number, and what if I have some zeros, then what will happen? Simply, if I have one number which is negative, and also if I have a zero, one negative and a zero, for sure a zero is better. So I will simply have a zero. What if my negative number count is zero, which means I simply have a zero. So I will simply return a zero. What if my zero count is also a zero, which means I have no zeros at all? I will simply return the negative number. And as my negative array had the positive values, so I did a minus here. And simply, it is not required. You can simply remove it also, because it will actually return the entire cases which you wanted. Although the code is big in general, but it is entirely what I spoke out. That, okay, I just bifurcated into 3 conditions, then again 3, again 2. I just repeat the same stuff as if else condition. Although you can easily go and check some better short way, but it will mostly be a simple, you can just go sort, simply sort. He was also doing the same stuff, just checking, okay, if nums.i sorted it, resulted. He's also the product of all, simply getting the product of all the positive numbers, then the number which is negative, to actually get the largest number which is negative. They have made the code short. You can also make the code short. It's just that stuff remains same, concept remains same. Get all the positive numbers, get all the negative paired numbers. If one number which remains is negative and you have no other number, get a zero. If no zero, return that negative number. As simple as that. I hope that you guys got it. I'll quickly go on to the comments and see what you guys are thinking. But yeah, meanwhile, build your own language UB. Shah Pandey, can we sort them and then take even numbers of negative numbers starting and take positive numbers from the back? Can we sort them and take even numbers of negative numbers? Even numbers, like even number of numbers, or even numbers itself, like that is because see, we have, if the numbers are negative, we have to take the even number of numbers, not even numbers, right? Because it's positive negative, so negative and negative, which is positive, that's the reason. Number should be 2. And okay, cool. After 5 wrong answer, I did it. Peace. Oof. Vitamin Protein. That is actually a good name. Like legit, I smiled when I read this name, Vitamin Protein. But yeah, meanwhile, the folks are watching. Can we please smash the like button and reach 8 likes? Because for sure, we're gonna see the last question, and I swear, that was a very easy question. 4th question was a very, very, very easy question in comparison to the 3rd and the 2nd question. But yeah, if you have to implement it from scratch, it might be hard. But if you have known, okay, what is sieve, what is simple graph, DFS, if that is known to you, that's very easy. Building logic is very easy for the problem. But yeah, we will see that. But can meanwhile we reach to 80 likes? That would be great. 80, bus 80, just 4 more. That would be great. Meanwhile, let's go into the comments again. I do think there's a competition. If 50 apply to every JavaScript opportunity, 49 waste their time. JavaScript is too popular. Make use of. Something is going on above. Oh, something is going on above. Oh, I missed many comments. Oh, I'll just going on again back. Waiting for the last question. Yeah, cool. That's Abhi 8. Yes. At what time? Yeah, I just told that. Can 3rd question be done by using tries? 2nd question. Yeah, that can be done for sure. Empire Gaming. SK Fardeen. Could not do fourth one. No worries. We will see the fourth one also. Third one was easy. Yeah, that was correct. Just the implementation stuff. But still, if you have not done that, still we showed you the entire thinking approach. Just think from that perspective. That would be great. I think it would be better if you just write the code live and explaining thought it through it. Take time. See, people a few times want that to go fast. Few times not. So see, the code writing part is just okay. At what step you just write that? Okay, I'm not showing you the code entirely. I'm just walking you through the code, which means from this part you go to here, you go to here, you go to here. Now let's imagine I'm showing you the code. Just close your eyes and focus on only the area I'm showing you. I just go through the code in the entire order of how it is being written. You just wrote this line, after that you wrote this line, after that this, after that this, and then you had this entire program. That is how, because it's very like not so much useful if you just write this code down, because I cannot understand the concept of writing the code down. I can simply explain that entire line by line stuff rather than just writing that stuff down. Writing stuff down entirely means, okay, you explain that stuff, but yeah, I've seen people do it. I appreciate that, but I think it wastes a bit time, but we can try that. But yeah, for sure. I like last time also in the stream I asked if I should write the code down or I should explain that. But yeah, people said okay, explaining was fine. That works. That works. Third one, maximum subsequence product. You can have that. Hey, I am big fan, Tanu. Thank you, Tanu. Are you single? God knows. Q4, I already knew it was a union find. Still cannot implement. I don't know, every time the component being connected, people say it as union find. Yeah, it is actually union find, but it is very simple. You don't need union find at all. A simple DFS traversal, which means finding the component, would do. As simple as that. I don't know why everyone just goes to union find. It is actually, for sure, every problem which is of components, it can be implemented by union find, but still, when the problem is easy, we should focus on finding component. Component finding is not the only purpose of union find. Component finding can be done by a simple DFS traversal. So please, whenever you have to find a component, just do a simple 3 or 4 line DFS traversal and simply go on. Please don't go into union find algorithms for simple DFS traversals. Please, that takes a lot of time. Cool. Why blushing? That is what it is. UB, guys, I want to get a coding job. Which language has the least competition to get a job in? See, the competition you go on to, okay, you ask folks, but yeah, I just recommend just learn the skills, because language learning is not the task of problem solvers. Language learning, see, if I know one language, I can convert that code to any language using that chat GPT or any other tool. So language part is never important right now. So yeah, you know, Infinity Gaming, when they are in even numbers, yeah, correct. Ajit Shiva, similarly, to find the subset using bit masking, yeah, that can also be done. Pratik Agrawal, good work, bhai. Thank you, Pratik Agrawal. Pratik, I think it is I know, like, if that is the Pratik Agrawal which I know, huge shout out to you, bro. I could not find, like, see the picture because it is very small, but yeah, I guess it is the Pratik Agrawal which I know. But cool. Infinity Gaming, can we sort them and then take even numbers of negative numbers and then all positive numbers? That is correct. Sort of Burjwal, hey. But yeah, meanwhile the folks are watching, you can just write your comments down, and also can we please reach to 85 likes? That would be great. Just 2 more. Maggie मच जाती 2 मिनट में, तो तुम वो भी कर दो 2 मिनट में. Cool. Can we use subset? Yeah, that we can. It was easy problem. I'm stupid. I got stuck in edge cases test. That happens. My logic was not working for 0 minus 1 because it should return a 0 rather than -1. Thanks for not answering my question, UB. What you asked, bro? Guys, okay. I just answered that. No worries. Shah Pandey, nothing less has less competition, but if you learn JavaScript or Python, you chance of getting a job. Yeah, correct. That is correct. Ajit Shiva, build your own language. Shashit Pandey, can we sort them and take the even numbers of negative numbers from starting? That's correct. After fifth, I do that. I do think there's a competition. If cool. Chinmay Moy. Not sorry if I am pronouncing that wrong, but yeah, cool. Sometimes you are just terrible at explaining a solution. That's correct. Pranay, lead code problem setter, gone crazy. Third problem, correct. SK Fardeen, Max heap से मेरा code 20 line में हो गया. You can do this code in 5 lines also, 3 lines also. You can do it in 2 lines also. No worries. You can explain in chat if fourth में corrected components का feel आया but code नहीं कर पाया. No worries. If you get the feel, that's true because you need only one corrected component. That's done. Shubh, logic was too easy, but I was having some issues in implementing. I lost my calmness. That happens. Shubh, Chanchal, I was not able to handle edge cases. How to think about them? When we think about the edge cases, we just bring the problem down to the small combinations. Only positive, only negative, only zeros. Positive zeros, positive negative, positive like only zeros, negative is zeros. So when we think of edge cases now, we just think of very extreme, very small case, very negative, only zero, only one element like this. That's the reason we just, by this we can solve edge cases. So when we have to find the edge cases, just go very extreme. Just one element, just no element, just having a value very high, very low, only negative, only positive, only zero, negative, positive, like this. Just go in extremes and you will find the edge cases. Cool. I was not able to handle edge cases. This problem was just how good you are at edge cases. Got to wrong, like that's correct. Vitamin protein, haha. Since n is 13, here you can use bitmask to find the subset of all the products. That is correct. Shubh, Infinity Gaming, I did the same. That is correct. Finally did all 4 questions. Great, Shashank. Shubh, English में समझाओ ज़्यादा impact पड़ेगा. Cool. Shash Pandey, can you use Hindi in between? Like करके screen तोड़ दो सब. That is correct. Yeah, yaar, you have not reached 85 likes. I was reading comments. Just one more. एक और. Let's go forth. Let's go. Can you quickly explain using bitmasking technique? Bitmasking is nothing but just having, see, you have to find, either you have to visit a particular this part, which means if we just go back and see, where's my pen? Yeah. So basically, see, it is that okay. Whenever we say that we visit a node or not, then we say okay, it is visited, it is not, it is a visit, it is not, it is a visit, it is not. So simply visiting that node, simply we just have, if you have not watched the last to last stream or maybe before that, we had a proper question on bitmasking, that by DP also, that how we just solve it. But simply bitmasking is nothing but grabbing that portion as visited, that okay, if you have this part as visited, you have this array at this index I, you have 2 options. Either you can visit that or not. If you skip that portion will remain 0. But if you visit that, you can just mark it as 1. Now, you can have a vector of visited, but it is better that okay, the length is small, the length is only up to 13. So you can have a vector of visited of length 13. That would also work. But that thing 101010, it's simply a binary number itself. So you can convert this number into a binary number, which means a decimal number itself, which means if I just say okay, let's say the number is 321, and if I say it is visited, it's not, it's visited. So the number, it's saying okay, it is showing us an array of visited, which means I can convert this same array of visited into a simple binary notation, and that notation is nothing but 1 to 4, which is 5. So that state of being visited, I can tell by simply a binary notation or a simple number, which is 5. And that is how you can reduce the space and also time to actually go and find what was already visited and what you can visit now. That is how you can simply use the bit masking technique. भैया आप कौन सी कंपनी जॉब करते हो? Being void, Goldman Sachs, bro. That is great. And see, bit masking is a bit overkill for this problem because it is considered a bit hardly. If you are good on bits, you can do it, but it's involving DP, bit masking stuff. I'll say just go via the standard greedy approach. That would work because see, firstly, when we see a question, greedy should come in. We should validate greedy as not. But yeah, we just look at the constraint because see, you can have two approaches when you are solving a problem. You saw the constraints, you saw, I can simply make a bit mask and solve it. Good. You saw the question, you saw, okay, it's simply a maximum product. Simply do a greedy approach, grabbing the maximum products, and that would be good as well. So yeah, that was, you can simply go and check our, not sure it was last to last stream or last to last stream, in which we actually explained the entire DP plus bit masking thing. By that you will get or you can just write DP plus bit masking by Aryan Mittal on YouTube. You will get a video at the top itself, and you can just go and walk through. In that video, I have explained every operation to make the bit set, to know if the bit is set or not, which means to know if if that element is already visited or not. So yeah, that is all. Please start fourth. Yeah, for sure, Rohan, we are starting fourth. But yeah, meanwhile, can we guys reach to 40? Sorry, 90 likes, not 40. Please no 40. Cool. 90 likes. Cool. Greatest common divisor. I was saying fourth question, but it became as 40. But cool, no worries. Greatest common divisor, traversal. Problem is pretty simple. We are having a array as nums. Cool. Also allowed to traverse in between its indexes. We'll see how. You can traverse between I and j. Let's make it big. We can traverse between I and j. I and j are indexes. We can traverse between I and j. Firstly, I should not be equal to j, which means not overlapping. I and j should be separate. If and only if the GCD of the numbers at I and the index j is more than 1, which means they should have at least one common divisor. Only then I can move from index I to index j. Right? I can move from index I. Mark my words. As I am reading the problem, I am saying I can move from index I to index j if the GCD of these two numbers is actually something, which means more than 1. Right? Now, you know what is a GCD? It's the greatest common divisor, which means a common factor or a common any factor is there between the two numbers. Now, our task is to determine if for every pair of indices I and j such that I is less than j, mark my words, for every pair of indices I and j such that I is less than j, there exists a sequence of traversals that can take us from I to j. Now, we will look at this condition, but make sure if I have this array something like this, from this I, let's say it is I should be able to reach this, and this. Maybe directly, maybe indirectly, but I should be able to reach. From here, I should be able to reach this, and this. From here, this, which means every number which is forward. But we will see. Okay, just please imagine this part very carefully, because it will actually help us make the final part. But I'll just explain that a bit later with the example itself. But meanwhile, just look at this particular graph and see that every pair of I and j such that I is less than j, there exists a sequence of traversals that can take us from I to j. What is the sequence of traversals? We will see. And true if it is possible to traverse all these such pairs, and false otherwise. Aryan, shall I go at all the pairs? Sorry bro, you cannot. Firstly, you cannot. Now, cool, no worries. Now you know you cannot. Let's look at the example. 2, 3, 6. My task is to go from 2 to 3 and 2 to 6. 2 to 3 I cannot go because the GCD is not more than 1. But 2 to 6 I can go. For sure I can go. Okay, that is done. It's good. But I should have been able to reach to 3 also to make as answer true. Can I reach it? If I just go back and see, I can reach from 3 to 6. If I can reach from 3 to 6, I can know. From 2 I can reach to 6. With that I can reach to 3. So from 2 indirectly I can reach to 3 also. That is how from 2 I can reach 3 and 6. And from 3 I can easily see I can reach a 6. That is the answer. That's the reason answer is true. From 2 I can reach 3 and 6 both. 6 directly and 3 indirectly via 6. But 3 also I can reach, which means from 3 I can reach to 6 also directly. If we just go and look at 3, 9, 5, I can go directly from 3 to 9 for sure. Can I go from 3 to 5? From 9 to 5? Because the GCD is not more than 1. Sorry, I cannot reach from 3 to 5. Answer is false. Let's go to 4, 3, 12, 8. I can reach from 4 to 3. 4 to 12. Yep. 4 to 8. Yep. 3 cannot reach. Answer is false. Not yet. From 3 I can reach to 12. Oh, from 4 I can reach to 12. Indirectly I can reach to 3 also. Yeah. Good. I'm done. I am done. I'm good. I can reach to 4 to 3 also. Now considering 3, I can reach from 3 to 12 directly. Now 8 I can reach. But 3 to 12 to 4 to 8 I can reach. Which means from 3 I can reach to 8 also. That's the reason. It's also good. From 12 I can reach to 8. Yeah, I can. Simply. Yeah, that is good. So it's the reason answer is true. Now I will consider the same 4 element case with you. Just right now I am not going into very much. I'm just saying a simple stuff. I have to simply go from the I to all the next J's. As simple as that. It is the task which I have to ultimately see, and it should be possible. I also have to go from this particular index to the next. As simple as that. And also I have to go from this index to the next. Now you will see one thing very easily. If I have to go, let's say if I have anyway, I can reach from here to here. I can reach from here to here. Now with this, I can reach here also. I can reach here also. Right? If I can reach here, I can just go back here. So basically, you saw, with this one element, I should be reach every possible location. Which means, ultimately, I should be able to reach every possible location by just simple traversal. With this traversal, I started from 4. I was able to reach 12. I was able to reach 8. I was able to reach 3 also. It is a simple aim I had initially, right? Because it was a problem, right? From your index every I, you should be able to reach other all J's. So for I equal to 0, you should be able to reach all the J's which are more than it. So I'm just saying, okay, for this number, initially, for this number, which is at the index 0, I should be able to reach everyone. So for sure, I should be able to reach every node. Here to here I am able to reach, here to here I am able to reach, and here to here. Which means, if I just try to make a graph out of it, okay, all these nodes should be connected. But right now, I just checked only for the node as a 0. Can I just say by just having a check for the node as 0, which means the initial index I as 0, can I say, okay, if with this I as 0, I can reach every other location. I can reach here also. I can reach 8 also. I can reach 12 also. I can reach any number. If I can do this part for I equal to 0, can I say one thing? I can do it for every other I also. Because see, if I just try and go this same stuff for every I, it can't do. So I just said one thing. Firstly, if the folks are listening to that, I'm just asking you one question. Can it be possible if I just say for I equal to 0, if it is true that, okay, you can reach every other node which is after it, which means you can reach 3, 12, 8. Is it possible to say for surety, which means for with assertion, that for I equal to 1 also, you will be able to reach everyone. For I equal to 2 also, you would be able to reach for 3 also. Is it possible? Yes or no? Yes or no? And if yes, how? If yes, how? Just write that down quickly. But yeah, before that, can we reach 95 likes? That would be great. 95 likes. That would be great. Cool. Now, yeah, that is possible. How? Bhai vlog masta. Thanks, bhai. See, how? If I am able to reach from this 4 to every other node, right? If I am about to check for this 3, now I know I was able to reach from 4 to 3, which means I am also able to reach from 3 to 4 back. I know this part. Now, if I am able to reach from 3 to 4 by any means, because I know I was able to reach from 4 to 3 by one way or the other, I was able to reach, which means vice versa is also possible. I can reach from 3 to 4. If I have reached my 3 to 4, and I also know from 4 I can reach anywhere, so I can again go and check anywhere I can go. That is how I can make sure from every element I can reach back to the node 0. From every element I can reach back to the node 0, because for sure every number was connected with the node 0 itself, which means the index 0. By this I can say I will try to reach every number back to the node 0, every number back to the node 0, every number back to the node 0, and then from this node 0 I can just go back to any number I want. As simple as that, because initially I know I was able to reach from the node 0 to every other number. Thus, I'll simply make a graph out of it. When I say graph, I simply say, okay, I can reach from 4 to, I can reach 12, I can reach from 4 to 8. Okay, it is connected, and from 12 I can reach to 3. I'll just make a graph out of this, and I will just try and do a simple DFS traversal and see if this graph is entirely connected, which means it should be one graph entirely, which means it should be a one component. If it is the case, I will return a true, else I will return a false. Because you will see in this example, it is making two graphs or two components, but I want entirely one component, because if one graph is connected, if it is connected, I am able to reach from every node to every other node, and that is what I wanted at last. Now, you got to know, you will simply do a connection and simply do a traversal in the last, do a DFS traversal, and simply you will see, okay, if it is one component, and if you have not known how to find component, how to do a traversal, simply go and watch our bar graph series. In that we have explained what's a component, how to find a component, if there's one component or not, if the graph is connected or not. So basically the graph is connected right now. I will just go and check, starting with this node as 0 or the index as 0. I will just do a simple DFS traversal, check if the graph is connected, which means the number of nodes in this connected component, it should be exactly n. If it is the case, the graph is entirely connected, and I will return a true. Cool. Now the task comes is how to actually connect these nodes, and that is very easy. Simple. If I had a 4, what's the number? 4, 3, 12, 8. 4, 3, 12, 8. You know how these numbers were connected. My 4 was connected with 8. How? Because I knew one thing. One thing is I can go on to every number and check, okay, hey bro, can you just connect it? Hey bro, can you just connect? Hey bro, I just asked 3, I'll ask 12, I'll ask 8. Then from 3, I'll ask 12, I'll ask 8. But that will make us n square. So directly I should know initially by seeing 4 will connect to 8, 4 will connect to 12. That's it. That's it. How I will do that? Simple. I know how they are being connected. They are connected when their GCD, greatest common divisor, the factor which divides both of them, if it is true. So what I will do is I will simply find the prime factors of every number. Its prime factors is 2 into 2. It is 3. It is a 2 into 2 into 3. It is a 2 into 2 into 2. And I just want the just to know, okay, if there is any factor or not. So I will just remove the like extra ones. I will just simply have what are the unique ones, unique prime factors. See, you can have anything. You can have the prime factors, you can have all the factors, all the prime factors, but simply I am just concerned about if they have any factor as common. And when I say any factor, I just specifically mean, okay, just bring every number down to the smallest prime factor and then check, okay, if that number has any common prime factor or not. Now I just go and bring every number down to their prime factors. Now Aryan, you just made the prime factor for every number, which means it will just become a list. It will become a list. It will become a list. How big is this list? See, you know the numbers, it can be n. For n numbers, you can just make a list down. That is not a very big list. Why? This list, it at max, although it will never go, but at max can go to 16 length. How I found 16? See, at max, the number of prime numbers, see, smallest prime number is 2. So if I just multiply all these numbers, 2 into 2 into 2 into 2, up till what? Up till 2. And then I have to find the biggest number because it is the number itself. So if I just look at the constraint, the maximum number is 1e5. 1e5. So 2 raised to power 16 is bigger than 1e5. So for sure, 16 times the 2, which is the smallest prime factor, can come. So for sure, as soon as a 2 into 3 comes, into 5 comes. Now with this uniqueness, it will actually go on and keep on reducing. For sure, the number of numbers will always be less than 16. That's the reason. The length, okay, the length wise it is n. The breadth wise it can at max go to 16, although very less than that. That's the reason I can just actually make the factors down. Now I made the factors down, good. But what I will do with this, I can simply know one thing right now, right? I simply know that, okay, if this is a 2, this is a 2, this is a 2. For sure, I can connect all of them. I can connect this to this, this to this. Simple that. How I will connect? Right now, I made from numbers. Arey chal jaa yaar. Yeah, from numbers, I made the prime factors. And by the prime factors viewing itself, I know 2, 2, 2 is there, which means they have a common factor, a common divisor as 2. For sure, they have a greatest common divisor as well. That is 2, which means they can be connected. While I have an example as 3, 3. Now let's take another color. This. So 3, 3, which means they also can be connected. Now I know, okay, I have to connect the nodes on the basis of their factors. So let's just bring the factors down, which means let's reverse the script, like flip the script. Reverse the script kya hota hai? Let's flip the script. That, okay, rather than the numbers to factors, have factors to numbers, which means I will just make it 2 as a prime factor has all the numbers as 4, 12 and 8, right? The next number, which is 3, have all the factors as 3 and 8, 3 and 12. Now it can at max go to 16, right? And this length can also at max go to n, right? Although it is a very worst case, it is never gonna touch this part itself. But I took, whenever I consider problem, I took the very worst case, which is beyond the limits of actual problem. Cool. Simply, now what happened is, you know, the node 4, 12 and 8 will be connected. The node 3 and 12 will be connected. As simple as that. Now your job is to just build a graph on top of this node. How you will build a graph? You know that, okay, all these nodes will be connected. So simply draw an edge between the consecutive nodes. I draw an edge between 4 and 12. I draw an edge between 12 and 8. As simple as that. Now I know, okay, all this will be connected. So I draw an edge between 3 and 12. Now, when I draw an edge between 4 and 12, it becomes something like this. Between 8 and 12, something like this. Between 12 and 3, something like this. Thus, the graph is finally made by drawing an edge like this. I just grabbed, okay, it is the prime factor. For this prime factor, all these numbers are there, which is the number in my nums. And by this, I just went on to my nums entirely. Just adjacently, I'm not making the entire graph, which means n square edges. I'm just because see, my main task was to connect this entire node. So I'm just connecting every consecutive edge to just make the entire row as connected, right? Thus, I just connected consecutive ones, because by the consecutive connection also, the entire row can get connected and the number of edges required will be minimum. That's the reason I just did an entire connection. And then ultimately, I repeat the same process for all the prime factors. And ultimately, I have the graph made simple as that. Now, when the graph is made, and for sure, right now I have written the numbers, but numbers can be same. It can have the okay node. This node is it also has a value as 4. What if? Because it is like nothing but these numbers. Now it can happen now. 4 again comes. So I will just have a unique identity, which is the indexes. So for every number, it will be represented by its index. But yeah, before that, if we can just reach to I don't know how many likes are there. But yeah, if we can just please increase the likes. Yeah, what I'm saying, because I cannot see the like count. Okay, if we can just reach to 105 likes, that would be great, right? Cool. So basically, what will happen now is I will just represent these nodes as simple by the indexes. Okay, index is 0, index is 1, index is it was 12, right? Index was 3, 2. And index is 3. By this, the indexing, the nodes will be unique. And then ultimately, as my graph is made, I'll just simply go and do a simple DFS traversal to check if the graph is connected or not. Which means by simply starting my DFS traversal from the node 0, I'm simply visiting the entire graph. Which means simply by this visiting of this connected component, I will just count the number of nodes in this component. And in this component, the number of nodes are n, which is the actual number of nodes in the beginning, which means the entire graph is connected. The entire component is the entire graph, only one graph, which means this entire graph is connected. And if the count of number of nodes in this component is not n, which means it has some blockage, it has some blocks, it is some missing part, for sure, you will say a false, and this is how you will do it. So now you understood, okay, how you thought, you saw the problem, you try to go on the example. By example, you try to build, okay, I need to reduce my complexity from this n square because I can't go on to every edge. Now you try to build the edges by yourself, and then you figure out, okay, from the index 0, if I just try to connect every other node, I will be able to reach every node. So by just connecting my entire graph, I will be, because ultimately my aim was to reach from every node to every other node. So I just tried to build that edges. Now, by that I got to know, okay, I can reach from every node to every other node. By that reaching part, what happened to us is, I can just now and try to make that graph and try to visit if that graph is connected or not. Now, how to visit the graph? Just make the edges. How to make the edges? Edges can be made if they have a common factor, which means the main problem was saying they should have a GCD as 1, like more than 1, which means they should have a common factor or a common prime factor. So I brought every number down to the prime factors they have. Now I know all these numbers having the same prime factor need to be connected. So I just made, okay, the prime factor to all the numbers down. Prime factor all the numbers down. By this, all the numbers down, which means I will just connect all the numbers having the same prime factor. All the numbers having the same prime factor. Now, when this entire nodes of same prime factor is connected, ultimately, I can simply show by simply traversing on the entire graph if this has entirely as n nodes. For sure, the graph has only one component, and that is having a size of n, and that is how you will find the answer. I hope that you guys got it. Sobit Gupta Soja Bhai, for sure we will just sleep. But yeah, if we can just reach to, you were at 101 likes, but yeah, can we reach to 100 likes? Okay, earlier it was 101, but now I'm seeing it's 109. Can we reach 100? And if 100, then for sure, I was about to ask for 105, but you guys reached 100. Good. Let's quickly jump onto the code. It's pretty easy, but yeah. Meanwhile, folks, it will be great if we can reach to 100. Just one more like, and we can reach 100. We had reached 100, but earlier we were at 101. So if we can reach 105, that would be great too. But cool. Let's quickly just have a quick glance to the code. See, very easy. Simply, firstly, I just did call a sieve. Now, Aryan, what is the sieve? See, if you don't know what a sieve is, sieve of Eratosthenes is an algorithm to find if a number is a prime number or not, but it can have a multiple use cases. So basically, how my sieve works is, I'll show you that, okay, see, sieve is an algorithm which can find and tell you if the number is a prime factor in O of n log n log n time, which is nearly O of n log n, to be very vague or very layman terms. But for sure, if you just go and look at the my sieve code, it basically has one extra stuff. Although I'll highly recommend just get this code as a snippet and use this entirely whenever you want. I just use the same stuff. I just use the snippet part because it's very standard, very generic. You can just write the same stuff down again and again. In an interview, you have to. I will recommend to practice that, but practice that while you are practicing, not in the contest actual, because you can write down. Maybe it will actually remind you, but it's up to you how you want to do it. Practice offline or practice in the contest itself. But yeah, sieve, simple sieve. The only difference in my sieve is it will also store the smallest prime factor of that number. Now, if you had remembered how the sieve works is, it will just go on to every number starting from 2, and then every multiple of 2, which means 2, 4, go on and go forth, 6, 8, like this. It will just try to say, okay, every other number which is more than it, which is 2, 4, 6, 8, like so on and so forth. It will just try to say, okay, all the numbers which are multiple of my now prime number, because I was 2 as a prime number, all the multiples of it are not prime at all. So it will just say, okay, if this number is a prime, then all the multiples of it are not prime. So it will just go on to all the multiples of it and say it is not a prime, right? It will just go and check, okay, if it is a prime, firstly, if it is already a prime by default, firstly mark that smallest prime factor of that number as I, and mark that number is not prime, because for sure, if you can go from a prime number to any other number, that any other number is not a prime number. Then that's the reason I will just store a smallest prime factor for every number, because see, if I can go to 4, 6, 8, then the smallest prime factor for that number will be 2. As simple as that. That's the reason I just brought it down to just a simple addition of a simple if condition in my sieve code, and that would work. Now, how to use that part? I'll just go on and do a get factorization, which means it will just bring out all the prime factors of that number. Aryan, how will it do it? As simple as that. How? Let's see. If I have the number, let's say as 30. Cool. Now my x is the number which is 30. I have to find all the prime factors of 30. Now 30 is the number. I have to find all the prime factors of 30, which are for sure right now are 2 into 3 into 5. But my SPF of 30 right now is nothing but 2, because it is the smallest prime factor of that number. Now what I will do is I will simply divide my 30 number with the SPF of 30. It will become SPF of the new number. It will become a x equal to x was initially 30. It will become to a 30 by SPF of 30, which is 2. It will become a 15. Now I will again go and find, okay, what is the SPF of 15? Smallest prime factor of 15. Because it is stored. While I did a sieve as pre-processing, it was stored. For sure, if the folks are getting it and understanding that part, then please smash that like button. That would be great. Can reach to 105 likes. Just one more. That would be great. Cool. SPF of 15 is 3. It will again go and divide that. Again, it will become a 15 by 3. Again, it will become a 5. Now, again, we'll go and check, okay, what is the SPF of 5? Simply, it's a 5. Then ultimately, by this, it will just go on and become a 1. And by this, I can just simply break out. So you will see, okay, I just said, okay, if my x is not equal to 1, just go. And firstly, I ultimately wanted for that number x, what all are the prime factors, which means 2 is the prime factor, 3 is a, and 5 is a. So basically SPF of that number, which is right now 2, next time 3, next time 5, I'll just count its frequency. As simple as that. If you want, you can also have a vector, also have anything, but I just wanted all the unique numbers, so I just had this in my map. You can have anything, and as I showed you, your x becomes your x by SPF of x. Ultimately, you will just have all the unique prime factors, because see, this p dot first will have the prime factor, and p dot second is the count of that prime factor, right? Then I will ultimately, I just wanted only the unique prime factors, but you can for sure any day modify this code to get the prime factors and the count of that prime factors also, which is I can simply return in my result. Then I just simply return all the unique prime factors. In this case, it will return a 2, 3, and 5. Even if it had been a 60, then one prime factor would have come as 2, but still that 2 count would have been 2, but I am only concerned about the unique numbers, so it still would have returned a 2, 3, and 5. Cool. By this sieve part, this whole part went in, which actually did a standard sieve of finding the algorithm, and then I just did write this small code to find the factors by using this pre-computed smallest prime factor code. Now, by this, you can easily find the prime factor of any number in log and time. You know that part, right? Cool. Now, what happens is ultimately, as I showed you in the code also, I just went on to every number and brought down all the prime factors of that number, right? I just made this map. It will bring for this index I, let me zoom it, for this index I, what all prime factors are there for that number I. Because see, I know the unique identity of that number is the index. So for that index, what all are the prime factors? Because I just made it that list. It is the list which I made. It is the list which I made. For this unique number ID is initially 0, which means the unique number is ID, and all the prime factors, and all the prime factors, all the prime factors, all the prime factors. It is what I brought. And for sure, it's very less. It is for sure less than 16. Now, I wanted the map other way around, which means from the prime factors, I wanted to the numbers, which means I wanted the reverse map. So I make a reverse map, which means from the prime factors, which means here the ID is the actual index of that number, but I want from the prime factor to the number. That's the reason I just went on to this earlier map which I made, went on to every of the prime number of that map. Then from prime number, I made a reverse map to the index, right? As I showed you above also. Now, ultimately my reverse map is made, which is from the prime factor to actually all the numbers. Now comes the part of actually building a graph out of it. So what I did was simply, I know for this prime factor, the entire row with me, I need to connect this entire row because it is connected entirely. Now to connect this entirely, I just simply had the same stuff. Just connect the adjacent nodes so that the edges remains minimum. I just connected the adjacent nodes so that the entire row gets connected. Entire row gets connected. Thus, I can just simply make the graph. How the graph? Just went on to, because see, my prime factor, the entire row of that prime factor, which means all the indexes having that prime factor, I just go and went on building the edge between the consecutive elements. I just went on to my reverse map, which is having the prime factor to the numbers. Then I just grab the IDs, which is for this prime factor, what all IDs are there, because I'm storing the IDs as the unique identifier of that number. If the ID is less than equal to 1, which means only one node is there, I can't make an edge with one node, right? I need to have two edges. Two edges, I'm saying. Please don't misinterpret that. I need two edges. That's the reason I need two nodes. So if it is having only one node, just continue. But if it is having more nodes, just iterate on all the nodes. Now I just started from the 1, which means I will make an edge from I minus 1, which means I am just going on. I'll just show back with this. I'm just going on to every of these. Now I will have every of these. Now starting with this, I will just make an edge between this U and this V. Next, I'll just go on to this, and next I'll just make this U and this V, and I'll just make an edge as I move on linearly. Cool. Let's quickly go. I just make an edge, make the node U as the ID of I minus 1 and the node V as ID of current I, and I just made an undirected edge, which means bidirectional edge between U and V and V and U. Now my graph is made. I need to simply do a DFS traversal from the node 0 and check if the count of all the nodes being visited is actually n. So I just take a global variable as count. This is the variable which is global. I just initialize that to 0. You can do anything. Visited, to actually visit every node exactly once. In a simple DFS, we do simply like this. Now, simply if I just do a simple DFS traversal from the node 0, if on doing the traversal of see, it's the reason I just told you that rather than doing a union find, do a simple DFS traversal. Very small code, very small. Simply, if it is already visited, simply return, because we have a thumb rule. We will never visit a node again in a simple DFS traversal. So a simple DFS traversal. If it is not visited, mark it as true. Then also you are visiting a node. So basically you are counting one node. So basically my count is plus plus. Then simply, okay, I'll just go and have this. Cool. And then simply go on to all the neighbors of that node, because the graph is already made. Just simply a simple traversal. If it is not visited, just go and visit that neighbor. And this simple DFS traversal will visit all the nodes and take the count of the visited nodes. Now simply come back and check if the count is n, which means my entire graph is connected. I can go on from every node to every other node. I am good. Return a true. Else, simply return a false. That is how by simply using your number theory, your prime, your factors, and your graph, which is a simple DFS traversal and a simple connected component logic, you can actually find the answer for this problem 4. That is by simply using the small concept, sieve, number theory, primes, prime factors, GCD. This small concept actually helped you building this problem. That is how you can just solve this problem. So that is all. I hope that you guys liked it. Can we quickly reach to 110 likes? That would be great. Just one more like, that would be great. And because soon we would be ending the stream, because I hope that you guys got it. Any questions you can just write down below. I will be happy to answer those. But yeah, if we can just reach to one more like, that would be great. 110. And yeah, just your questions, any doubt, you can just write down below. We would be ending stream in around 4-5 minutes. So yeah, that is great. Any questions, the problem, logic, first, second, third, fourth, any problem, any confusion, anything whatsoever, just write down below. I would be happy, more than happy to answer that. And भैया, how to think about edge cases? Okay, that is done. Bro, कल भी live करो contest के बाद. Bro, we do live after every contest. Bi-weekly live 11 p.m, weekly live 11 a.m. IST, and that is how things work for us. And we have been doing it for the past 1 month, I guess, right? We will do it until unless there's some vacation stuff going on. So yeah, try to make solutions as generalized as possible so it won't have too many edge cases. That is correct. Works most of the time. Please start fourth is done. Rohan Pradhan, Pradhan. Okay, sure. Oh, nice. I thought it would be quite hectic managing both of them. In last question was, I guess, DSU plus prime factor. See, you can do by DSU by components. I usually don't consider doing DSUs when the problem is easy. DSUs have their entire, power, which I don't consume in these easy problems. So yeah, for sure, you can do easy. Vlog Masta, thank you Sachin. For the folks who have not watched the vlog today, you can go and have a look at the vlog. That was Hunter crash and iPhone. If you don't know, like my phone, this phone broke down. I actually have, it's now not with me, but yeah, the box and all that stuff is, I have that. Okay, then that story, you can just go and check the vlog. That was great. The vlog will be coming more frequently. I guess yes. Question number 3 can be done with just simple recursion. Correct. Avinash Shukla, I thought the same but not able to complete the code on time. No worries. Shobit Soja Bhai, for sure going on to sleep. But yeah, meanwhile, if the folks are enjoying watching or having any doubts whatsoever, they can simply comment down below, and for sure, if we can reach to 115 likes, that would be great too. Just meanwhile, we are just going on to comments, because for sure we are just ending the stream very soon. So yeah, quickly, hey Aryan, big fan, are you single? Tanu Pandey, not sure. Code note, rank kya I bro aaj? Not good. It was 1500 or so, because the best part, I did the question like this: 1, 3, 4. And then I tried to have a 2, but then I just thought, okay, let's have it done. So it was around 1.5 or 1.600 something. Abhishek Mishra Mahajan, sorry, bit complicated. Can use map of prime to vector of IDs that can contain this prime. Yeah, I just showed you the logic. While doing the contest, I just don't go on too much, overcomplicate my thinking. Whatsoever I am thinking at that moment, I just implement that. It's the reason I just don't make the notes of these problems, because the code I have written, it's not the purest, not the best, shortest code possible. It's the reason. It's just to show you the intuition, the logic, and how you can implement that. Not the best code you can see on the market whenever I'm showing the contest problems. So yeah, that is. But yeah, if we are seeing the problems which are done, we have them as daily, they will have the best code possible, most cleanest, best code, ekdam crisp, concise, all that stuff. But yeah, meanwhile, if the folks are still watching, can we reach to 115? Just 3 more likes, just 115. That would be great. But meanwhile, your username is Aryan_0077. Gaurav Bhai Gaurav food. I'm very bad at names. Please forgive me. Please. Even my name also, people have said it as, I'll not say, but yeah, that is great. Code note, your username, I've given that. Ajit Shiva, thank you for your dedication. It's because of love of you guys. Ajit, Abhinav Garg, bro, same approach follow करी, फिर भी TLE आ गया last case पे. Last case as in, like, you are saying for third, which fourth problem, TLE. Maybe you can try to optimize a bit stuff, take a boolean, take visited, not visited, all that stuff. A bit optimization. Maybe you can have reduce the number of vectors you use, try to give by addresses, try to have constants. Leetcode at a very edge point, just give fails. Code note sahi hai. Cool, thank you. I guess the people have no questions, but yeah, before that, if we can just reach to 21, I say 115 likes, that would be great. Just one more like, and that would be great. Meanwhile, we will end the stream in 3 minutes at 12:45 a.m. Bro, last I am 21 and BCom completed. ANBU. Cool, no worries, bro. That is great. Best part is you are starting the programming journey, programming all that stuff. That is actually great. I wish best, and please be motivated and stuff. And yeah, for sure, if the folks who are watching who have filled the form for VP class guidance, they can just go and look at the emails I have submitted. I have shared the links for where you have to go and come, because tomorrow we are gonna have a VP membership. Every Sunday, as we say, that we will have that live stream discussions with the members to actually go and guide them and see what they have, whatsoever progress they are having on all that stuff. So please make sure that if you have applied, if you have gone filled that Google form, which we posted in the OA video, then please go look at your emails. You will have found your email from me, from Aryan. You can just go and check Aryan Mittal email at gmail.com. That was the email from which I shared that. But yeah, if you had just got that email, if you want, you can just start. You can just fill that Google form and apply. But if not, we are starting from tomorrow. Let's see. Let's have the folks joining in. We will just guide them. We will just have one-to-one communication. See what they are having, what the progress they have, how to improve their ranks, time, code, intuition, logic, all that stuff. So yeah, that is on that part. I hope that you guys liked it. Bro, I'm 21. I'm become computer. I just started coding. Can I crack Microsoft software? It's not 6 months. See, if you are starting from scratch, it will take 3 to 4 months. But if you have a basic idea of DSA, which means basic array stuff, basic DP, basic like binary search, all that basic stuff you have done, it will just take 2 months to crack any company you want. When I say any, I don't consider the ones which might ask very hard questions, but the like normal ones, which is Google, Microsoft, Amazon, Goldman, D. Shaw, like all these like normal companies, you can just crack any of them if you have the basic knowledge of DSA, which means like graph, binary search, DP, all that stuff. If you have a very basic knowledge, okay, then you can just crack any company in 2 to 3 months. If you have like no knowledge at all, then still you can crack them at around 4 to 5 months, and that would be very, very, very easy. Just that we need a bit dedication and hard work, and also consistency. That is very important. And yeah, that is all. I hope that you guys liked it. It is 12:45. We are ending the stream. Before that, if we can reach to 120 likes, that would be great too. But yeah, I hope that you guys have no questions. See you in the next video. Goodbye, take care. Faarte rehna. Cool. Bye. Thanks, bro. Thanks to all of you joining. 31 peeps. Cool. Thank you. But yeah, meanwhile, if you are just going and you have not liked, then please, one like. That would be great. Cool. Thank you so much for joining in. Thank you so much for coming in. Thank you so much for solving. Thank you so much for being consistent on solving the contest problems. Actually giving the contest. See, giving the contest, only solving the problems will not help you. But giving the actual contest will help you. So I'm actually very grateful that you solved the problems in the actual contest. And then you came to Upsolve. It's actually a very good thing. So yeah, a huge congratulations from me that you actually take an initiative to solve the problems. Cool, bro. I have done some 300 plus LC problems, but still I find new DP or recursion base, I get stuck. See, DP is nothing but recursion. And see, when we say we did problems, is never about only the problems. It's always about, for every problem you did, how much you learned from that problem. So for sure, only the problems will not count. It's the reason I just bring out the problems daily. See, just write down DP problem solving by Aryan. It has just around 24 problems. Just solve those 24 problems in that way I have showed. And after solving those problems, 24 problems, which means if you just go and write down, I'll just quickly go and write down that same stuff for you guys. Just simply go and write down symbol that. Okay, I have to open a simple tab. Just go on and just write down on simple Google that youtube.com. Just go and write down DP problem solving, like anything. If you just go on and check Aryan Mittal, cool. Just go and see, if you want to get good at anything, just go and have a look at, see, if you have the DSA problem wise, just go and just have a look at these 24 problems. It is very well explained. See, just go and see, it is very in detail explained, from intuition, how to find the intuition, how to go on in the deep. So just go and solve these problems. I swear you would see. And when I say solve, please, before starting, think, as soon as you get the idea, okay, you were not able to solve the, let's say, recursion, you got the recursion, please try to memorize by yourself. Okay, you got the part of memorization, just try to implement by yourself the bottom approach. If not, then have a look at the problem, then have a look at the video. Just pause the video, just go back and solve it. Just come back, solve, like, have a look, because having a look is also important. Maybe something I'm saying new, which is actually more optimized, which is actually more better. So please go and have anything. See, I'm saying anything. If you want to get good at graph, just go and watch this, like this graph, this array. You can watch an array for graph. Just go and watch this graph problem playlist. It will just find it will just help you to build the intuitions, because these problems are just random, not ordered at all. Which is, if you want to go and have a look, okay, you can have the playlist of DP, you can have the playlist of our bar graph series. But if not, simply go. If you want to build the intuitions and want to solve the problems very frequently and randomly without knowing, okay, what's being applied for the specific topic, let's say graph, DP, all that stuff, then simply go and do the playlist of the problem solving, because the problems here are random and the intuition will be built. If you want to solve the problems basically random, let's say DP, like random topics itself, just go and have a look at this 150 questions which are the most important ones. Or maybe we also have the entire playlist for the topics, like the entire Leetcode problems, which is entire random problems which you can have. If you can just go and look at the playlist, I don't know where it has gone. Where it is gone. If I just go and have a look at, you can have, yeah, Faang interview questions and solutions. If you want the entire ones, which means mix of easy, medium, hard, just go and have a look at this playlist. So basically, it's the reason I have just made this playlist for you guys to actually try and use this stuff. If you want to build intuitions, just go and solve this topic wise playlist, because see, lecture will help you build the topic logic. This problem playlist will help you build the topic intuition, and this, like the playlists which are whole global, which have everything, which means this Faang playlist or basically this 150 question playlist. So basically all these will help you build. Where it has gone? This is like this 150 questions. So I'm basically building out the topmost 150 questions. See, although I have actually built the entire sheet for the questions of 169, but let's say now, because see, all these questions are old, but as the questions are coming in, some interesting questions are coming in, so I just add in this playlist of 150 questions. I have an aim of, because see, all the lists are made and they are not updated as such, but I want to keep these lists as updating. That's the reason I have just made this very early, back 3-4 months back, and I just keep updating with any interesting problem I find, any combination I find. It's the reason. Please go and utilize these playlists. It's the reason I just take time to club the problems in some playlists for you guys to actually go and have that. Cool. I hope that I was able to solve your doubt. Right? How to maintain notes. Cool. For the folks who are still watching, although we had to end the stream at 12:45, but still some folks questions, just answering that, we will end in short time. But if we can just increase 2 more likes and reach 125 likes, that would be great. Meanwhile, bro, I have, that is gone. One last question, bro. Is this going to be private? Which private? Answer. Mostly at 3/4, really 4/4. Even after analyzing too much, what can be the problem? See, problem is never the 3/4. It's always what topic is being used in that problem. Solving 3 questions, it can be easy also. Solving 4 questions, it can be easy also. It's always on, okay, what question, what was the 3rd question which you missed, what was the 4th question which you missed. It is always on what you missed, right? And not on the number of questions to solve. How to maintain notes for this, man? I mean, do we need to have to resolve the questions after some time? I'll highly recommend, if something you find unique, interesting, which you have not studied so far, maintain a notes of that. If you find anything, let's say for this question, you find you have not studied, let's say prime sieve or factors or components, add in graph the components, add in number theory, prime sieve, factors, all that stuff. So please make the notes of the topics which you are using. And also, if you have space, bandwidth, and you can remember, please also add the questions and a small snippet that you can use that later. I hope that you guys liked it. Thank you so much for joining in. Thank you so much, Satish, Tejas, Nikhil, Anu, being Anbhu, no, sorry, the A and B U, being Void, Code, Note, Abhinav, Ajit, Gaurav, Abhishek, Tanu, Shobit, Avinash, Doom, Krishna, Rohan, Sachit, being Void, Shank, Pranay, Shubh, Shashank, Ajit, Shubh, Vitamin Protein. Thank you so much, guys, for joining. I love so much to you guys. Thank you so much. Bye bye. See you. Goodbye. Thank you so much. Bye bye. Ending stream. Bye bye. Cool. Thank you so much for joining. Thank you so much. Bye bye. Cool. Bye bye. Thank you.